So the first and most important thing to understand here is the interaction between ABS objects and how they're handled by the AutoCAD platform and their relation to the display representation that's used for those objects. So what I mean is that in a standard plan view by default, ABS objects are either going to be in a one-line, two-line, or plan display representation. Now this means that as far as the AutoCAD platform is concerned, these objects are 2D flat objects with no elevation. So in this case, that's what we're viewing in right now. We're actually in our MEP design display display configuration right here. What we'll see is that, like I said, these items right here are above each other in space as far as ABS is concerned, but in this particular plan view, it's a flat drawing. If we were to switch and go over to an isometric view, we'll see that we're now viewing these objects in their model display representation. So in this case, as far as the AutoCAD platform is concerned, these objects now have elevation, and they all have they're basically 3D faces. So if I were to go ahead and switch to a visual style, you'll see that these objects all have faces and they're screened and they look nice. But when we are viewing them in a top view, you will see, when we're in a 2D wireframe, you will see that they're flat objects. So in this case, the interaction between this solid block, this ACAD solid, isn't being factored into this hidden line calculation. But if we look at it again in our pan view, you'll see that these objects are indeed above this block. So you can best illustrate this flattening effect by switching immediately to an orbit mode while looking in plan, and you'll see that that is indeed a flat object. As soon as I regen, they now have size to them and elevation, and the reason for this is the way the display configuration is set up. So if we go into our display manager and we look at our display configuration that's used MEP design, we'll see that it breaks it down for view directions. Basically, if we're looking at it from the top, it's in plan. Anything else is going to be in model. So this model display set, so if we look at it, is going to be viewing all of our ducts in a model display representation, and the same thing as our pipes. So that's why these objects have 3D elevations to them as far as AutoCAD is concerned. So if we want to go ahead and have them factored in using AutoCAD hidden lines, not ABS, we need to have them viewed in their model display representation. And of course, if we are viewing them from the top, by default, we're not viewing them in their model, so as a result, we're not able to get the hidden line effect you're looking for. And if you have CAD duct solids that are coming out of CAD duct, they're not going to interact with these ABS objects. So the simple fix is to go ahead and make a change in your display configuration to use a model display set in the top view as well. So if I go ahead and switch this over to model and hit OK, these objects are now actually in their model view. So if I were to go ahead and start planning here, you'll see that it's not perfect here, but those objects will all appear, and they actually had a thickness to them and an elevation. Now if I were to go ahead and switch over to a 3D hidden view, you'll see that in this case these pipes are now hiding this 3D block, and this block is now hiding this pipe that's physically underneath it. So as far as the AutoCAD platform is concerned right now, it sees 3D faces and 3D solids, and it can handle them in a hidden view. But so far as the ABS hidden lines feature is concerned, these solids are never going to be factored in because they don't get pulled into the calculation. But if you want to go ahead and have interoperability between the two types of objects, this is the best way to go about doing it.